Okay, again, you know the drill here. Get started on your bell work. You have about 5 minutes to get going on it. And so pause the video here, and then when you guys are all ready to go, you can start the video again, and I will go over this. So. Okay, so this is a review of what we did on Monday, what we did yesterday in the video that I left you. So with these, we've got H and K in here. So I want you to start by, because I think it's a little bit easier and we know what to do with H and K this way. Start by graphing that parent function. Start by graphing your 1 over x. If you want to, you can make the t-chart. You don't really have to, but you sure can. So remember, I pick numbers like -2, -1, +1, and 2. Sorry, my handwriting's not the best. Remember, I am trying this with a mouse. So, when I plug in -2 for x, I get 1 over -2 is -1/2. 1 over -1 is -1. 1 over 1 is 1. And 1 over 2 is +1/2, so +0.5. Alright, so we're graphing just this part right now. I'm actually going to graph it in black if that's okay with you. So at -2, I'm at 1/2-ish. At -1, whoops, rewind. You guys probably caught me already. This is again at -2, I'm at -1/2, and at -1, I'm at -1. Remember, your asymptotes, when it's just this a over x stuff, are always at 0. So I haven't translated anything yet. I'm just drawing up the parent function. And remember, I can't draw straight lines, so they don't really curve quite crazily like that one I just drew did. But, yeah. So, and then at 1, 1, and at 2, 1/2, I've got this. We'll just make this one a little bit smaller because I can actually draw. There we go. So it looks like that. Okay. Now, let's look at where my new asymptotes are going to be. So we're going to look on my vertical asymptote is that x equals h. And x equals h is the opposite of this here. So it's x equals -4. And my horizontal asymptote is at y equals k. And k is y equals -5. So vertical asymptotes at x equals -4, so that's -3, -4. Let's do this. So my new asymptotes move over here. And y equals -5. 1, 2, 3, 4, 5. Right there. Okay, so the asymptotes move quite a bit right here from the axis clear over to here. So there's my asymptote. Step 1. Step 2, plot your points or translate your points. This one, we do the opposite. So instead of going positive, we're actually going to go to the negative side 4 units. So we're going to go left 4 units. And this one, we do the same thing. So we're going to go down 5 units. So that's what H and K does. Always, always, always translates horizontally and vertically. So this point right here, I'm going to move left 1, 2, 3, 4, and down 5. 1, 2, 3, 4, 5. You notice these should be in about the same location, just on its new asymptote, if you will. Okay, so this one we move left 1, 2, 3, 4, down 1, 2, 3, 4, 5, right there at 1/2. So it is here. Step 3, draw the hyperbola, which I'm doing right now. And these points, again, move them left 4. Left 1, 2, 3, 4. Down 1, 2, 3, 4, 5. And left 1, 2, 3, 4. Down 1, 2, 3, 4, and 5. Okay, so the graph looks exactly the same. It's just moved to its new asymptotes. Okay, all right. What's the domain and range? Domain, remember, is everywhere where the horizontal vertical asymptote is not. So it can be any x value as long as it's not this one right here, which is -4. And range is every y value, so all real numbers not equal to -5. Right, if you guys need to pause the video, you sure can. Otherwise, let's go ahead and get started on today's notes. All right, section 8.2, part C. Graphing simple rational functions continued. And this is where they get a little trickier. Also, while I'm thinking about it, if you didn't fill out your half sheet yesterday with the asymptotes when you had H and K, make sure you do that right now. And then go ahead and get that half sheet out because we're going to add to it today as well. We should be able to finish it today. Okay. I believe our central questions have not changed. Do you recognize a rational function's graph? Do you recognize a hyperbola? And how do I graph rational functions? So we've got one more form of rational functions to show you how to graph here. Right? So in some cases, you might run into a rational function where you have this form p of x, some function, over q of x, some other function. More commonly, you're going to see this right here, ax plus b over cx plus d. Okay? So your asymptotes, your vertical asymptote will be wherever your denominator equals 0. So you'd be solving for, in this case, this cx plus d, you'd be solving for x. So for that example, your vertical asymptote would be at x equals -d over c. Okay, don't freak out yet. I'm going to put some numbers to it, and hopefully that'll help you a little bit. Right. Your horizontal asymptote is at the coefficient of same degree variables. And remember, degrees are the exponents. So these both have a degree of 1. And since their degree is the same, we're going to look at these coefficients here. So the horizontal asymptote in this case is at y equals a over c. Yeah, a over c. Okay, so I know some of you are looking at the letters and freaking out on me. Don't do that. Let's try this one with numbers here and see what we can do. You're not going to have to graph a parent function here because we don't translate normally. But let's start with our asymptotes. Okay. According to what I just told you, your vertical asymptote, so x, is equal to wherever the denominator equals 0. So this right here. When does 4x minus 2 equals 0? Some of you probably already see it. Don't need me to do this part, but some of you are needing this. So when does 4x minus 2 equals 0? Well, I add 2 to both sides. Add 2, add 2. I get 4x equals 2. And then I divide by 4. And you'll notice that x is equal to 2/4, or we'll call it 1/2. Okay. My horizontal asymptote is at the line y equals whatever the coefficient of same degree variables are. So you'll notice here that the degree of the numerator is 1, the degree of the denominator is 1, so I'm looking at the coefficients. Again, 2/4, so at y equals 1/2. Now this is going to take me an extra couple seconds. I'm going to scale this so that every 2 marks is actually 1, so that you can see your 1/2 nicely. So there's that. There's that. Two, 2, 2. And then I'll plot the intercepts here in just a second. Or I'm sorry, the asymptotes here in just a second. Okay. All right. So that should do. So my vertical asymptote is at x equals 1/2. So this is x equals 1/2 by the scale that I just drew in. And my horizontal asymptote at y equals 1/2. Now, you know that these are supposed to have little curves here and here. It should be a hyperbola. But to graph that, step 2, we're going to plot our x-intercepts if it's at all possible. Our x and y-intercepts if it's at all possible. I know that you're probably writing the words down and it's not making a lot of sense, and I totally understand. So we'll start, if at all possible, with our x-intercept. Our x-intercept is a point, and that point is wherever the numerator is equal to 0. So now I'm looking at, when does 2x plus 1 equal 0? Okay, some of you probably already see it, totally fine. I'm going to subtract 1 from both sides, and because it takes me so long to do this with the mouse, I'm just going to talk you through here. Subtract 1 from both sides, leaving me with 2x equals -1, divided by 2, which means I'm left with x equals 1/2. So my x-intercept is at the point -1/2, 0. -1/2, 0. -1/2, 0, right there. So that is my x-intercept. I think you can see that. Okay. Then for my y-intercept, I'm going to plug in 0 everywhere x is and figure out what y is. So to find my y-intercept, I do 2 times 0 is 0, plus 1 is 1, and 4 times 0 is 0, minus 2 is -2. These don't always end up the same, so please don't confuse yourself. So we're talking about y-intercepts. We're going to plug in 0 into this equation here and solve for y. And when I did that, 2 times 0 is 0 plus 1 is 1. 4 times 0 is 0 plus -2 is -1/2. So I have a y-intercept at 0, -1/2. These don't always end up looking the same, so don't confuse yourself. So here's my x and y intercepts. I know that this should make a hyperbola, so it should curve something like this. Okay, and here's where it gets a little bit tricky. It's not too bad. I said then mirror. So I'm going to mirror these points. And by doing that, I'm going to actually view the asymptotes more as an axis than anything else. So from like x-intercept wise, I'm 1 unit away from the asymptote. Do you guys see that? Okay, I'm 1 unit away from the asymptote on the x-axis, and I'm half a unit on the y, or for the y. So I'm going to go over here, and I'm going to go up half a unit instead of going down, and over 1 whole. So that should mirror it over there. Same thing here. I'm over half and down 2 from the intersection of the asymptotes. So I'm, if you want to think slope terms, we're going to go down 2 and rewind. Let's go down 1 and over 1/2. So from here, I'm actually going to go up 1 and over 1/2. So my hyperbola should be here, and it should be an exact mirror. So like if those, if the x and y axis were invisible, these black ones here, it would be a perfect mirror. Up 1 over 1/2. Yeah. Okay. Questions on that? You can pause. Go from there. All right. Domain and range. Our domain and range is always where wherever the asymptote is not. So again, my domain is all real numbers as long as x is absolutely not 1/2. Excuse me. And my range is all real numbers as long as y is absolutely not 1/2. All right. If you need to, you can pause the video. Otherwise, we're just going to keep on keeping on. Right? I do have this U try here, so if you want to pause the video for a few minutes, try this on your own, talk it over with your neighbor, that would be awesome, and then we'll get together and do it again when you guys want to resume. So, all right. So step one on these, remember, is always find your asymptote. So from your notes that you just wrote down, your vertical asymptote is where the denominator is equal to 0. So for what value of x would x plus 2 equal 0? You should find that that's x equals negative 2. And your horizontal asymptote is at the coefficient of same degree variables. Y equals, right here, same degree variables, so 3 over 1. Because you're noticing that that is invisible, so it's 3 over 1. 3 over 1 is 3. So let's plot those. X at negative 2 is right here. X at negative 2. And y at 3 is up here. And step 2, we're going to plot some intercepts, and we'll mirror those over in just a second. So, where is the numerator equal to 0? So if I plug in 3x minus 6 and solve, we'll kind of jot it over here. 3x minus 6 equals 0. I'd add 6 to both sides. Let's have 3x equals 6, divide by 3 on both sides. So x would be 2, correct? So I have an x-intercept, which is a point, it's not just a number, at 2, 0. At 2, 0, right here. So there's my x-intercept. My y-intercept, I plug in 0 to the original equation. So 3 times 0, 0, minus 6 is negative 6. And plug in 0 plus 2, I get negative 6 over 2. Well, let's simplify that. Negative 6 divided by 2 is negative 3. So I have a y-intercept at 0, negative 3. 0, negative 3 right there. Okay, that tells me where my hyperbola is on this side, and then I want to mirror it. So the way that I think about mirroring this is counting how far apart or how far away from the center of the asymptotes, or the intersection of asymptotes, is this, right? So I'll start with the x-intercept. We go, let's see, 1, 2, 3, 4, and up 1, 2, 3, right, to get there. So let's go 1, 2, 3, 4 again, and up another 1, 2, 3. Okay, this one's 2 away and 3, 6 down. So I'm going to go 2, 1, 2, 3, 4, 5, 6, right clear up at there at the top. And it should, so that should mirror it, and it should go that way. Okay, questions there? Hope not. Okay. If you have questions, be sure to ask me when I return on Wednesday, but hopefully you will have a chance to watch this video, and it is posted here on YouTube so that you can watch it over and over again if needed. All right. Our domain are all real numbers as long as it's not at the asymptote. So for domain, we're talking x values. So my asymptote was at x equals negative 2, so it can't be at negative 2. Notice that I can put a number, or I would put a number anywhere as long as it doesn't cross that line. Same thing with range, it absolutely cannot be at 3. All right. Okay. Now, I said, what if our rational function is in this form? That's what we were just talking about, the p of x, which is some function, and q of x, some other function. But, and here's the important thing here, but the degree of the numerator is less than the degree of the denominator. So far, we've only dealt where the degrees are the same. But what happens when the degree of the numerator is less than the degree of the denominator? Okay, Well, here's what happens. Your asymptotes change just a little bit. You'll have an asymptote, a vertical asymptote, where the denominator equals 0. That didn't change anything. But your horizontal asymptote will always be at 0. Okay. Now this stuff down here in red is just kind of a side note that is nice to know. In a your horizontal asymptote depends on the degree of P and of Q. So if P is less than Q, then your horizontal asymptote is always at y equals 0. So the very first ones we dealt with were a over x. Well, the degree of the numerator is 0, which is less than the degree of the denominator at 1. So remember, it was always at 0. Okay. Same thing on problems like this one. The degree up here is 0 because there is no variable. And the degree here is 1. 0 is less than 1. So this will always have a horizontal asymptote at 0. All right. And we just dealt with this one right here. If P and Q are equal, then your horizontal asymptote was at the leading coefficient over leading coefficient. So like 3/4. Right. And just kind of nice to know kind of thing. If P is greater than Q, you will not have a horizontal asymptote. However, good news for regular algebra 2, we won't deal with this. We won't get into this one as much. Maybe if you take pre-calc at some point, you would get into this. But for us right now, we're not doing this stuff. So, all right. The main thing I want you to take away from this slide right here is where the asymptotes are. So if the degree of the numerator is less than the degree of the denominator, so P is less than Q, then you'll have a horizontal asymptote at y equals 0. Right? So what does a problem like that look like? Right here, I've got the function y equals 2 over 3x plus 2. As usual, we start with our asymptotes. Okay, our vertical asymptote is still wherever the denominator is equal to 0. So our vertical asymptote is at x equals, if you need to, we'll do this on the side here. It's not really the side, but 3x plus 2 equals 0. Subtract 2 from both sides, you get 3x equals negative 2. Divide by 3, divide by 3. X is negative 2/3. Okay, you can groan with me. That'll be kind of a pain to graph. It'll be okay though, I promise. Right? And our horizontal asymptote, like I just told you, is always, in this case, at y equals 0. Why is that? Because my degree in the numerator is 0, which is less than the degree in the denominator at 1. So it must be at y equals 0. All right? And so then everything else is going to be the same. But let's start by plotting these points. And just to save us a little bit of groaning, I'm going to change this so that like this right here is 1/3, 2/3, 1. I'm going to do that all the way around because that'll make graphing that asymptote just a tiny bit easier. Okay. All right. So x equals negative 2/3. This one over here. Right here. We're not going to cross it. Right? And y equals 0 is right there on the x-axis. Y equals 0. As for the rest of the graphing, we're going to do it just like we just did. So we're going to find our x-intercept. Well, where does the numerator equal 0? Oh, hey, that won't happen. Let's come back to this. Okay. Let's plug in 0 for x and solve for y. Okay. Nothing up here. What's 3 times 0? 0 plus 2, 2. So 2 over 2 is really 1. So you have a y-intercept at 0, 1. Okay, that is doable. I can do that. 0, 1. Clear up here because I changed my scale. Okay. There is no x-intercept. Why do you think that is? Okay. There's not going to be an x-intercept because my asymptote is on the x-axis. So there is none. If you want to, you can make a t-chart and find another point. It's kind of up to you. If you wanted to plug in 1 or something, you totally can. But I know that the graph is supposed to hit through here and curve and never hit the asymptotes. So I'm just going to sketch it. Okay, just going to put my y-intercept in and sketch it. All right, then we'll mirror this point right here. Right, so it's over, there's 2/3 from this asymptote. So let's go 2/3 from that asymptote, but from the center. Okay, and it's up 1, and so in this case I'm going to go down 1, and I know it should look about the same, like, whoops, like right there. And there is my hyperbola. All right. Okay, and I didn't put it on here, but let's talk domain and range. We should know by now that the domain is everywhere as long as it's not on the vertical asymptote. So it's everywhere as long as x is not -2/3. And the range is everywhere as long as it's not 0. Okay. All right, any questions there? You can pause the video if you need to. Otherwise, your homework for today is a worksheet. The substitute should have that for you. And I'm hoping you have a little bit of time to work on it in class today so you can work together. Right. If you have any questions, be sure to ask them as soon as I get back. See you soon.